Alright, so today we're going to have a video lecture and the focus will be our midterm preparation. So if you go to our class notebook under exams, there's a file called for 2019 Midterm Form A, and this is the document that we're going to go over today. So feel free to print it out before you continue the video, or you could download the PDF and save on your computer, and then you could view as well. So let's go straight to this midterm. Number 1, simplify the expression. When we simplify expressions, you simply follow the order of operations, which is PEMDAS, P, E, M, D, and AS. P represents parentheses and the grouping symbols that you see, or absolute values. And then E represents exponents. MD, that's multiplication and division, perform from left to right as they appear in the expression. And the last level will be addition and subtraction. Same thing, perform from left to right as they appear in the expression. By looking at this expression, we do have grouping symbols. There are 2 pairs of them. Within each pair, we only have one number. So we're going to move on to the next operation, which is exponent. And we do have exponent. Therefore, I'm going to copy this 2 and then calculate what is negative 3 raised to the 3rd power. If you calculate that, it's going to give you negative 27. So what you could do is you could do negative 3 times negative 3 times negative 3 times, and then you calculate negative 27. And then we have this minus 1 here, but we're not going to deal with it. We have negative 5 squared, that's the exponent that we had to calculate. Negative 5 squared, that's going to give you positive 25. So you simply perform negative 5 times negative 5, that gives you positive 25. This is if we simplify the exponent, what's going to happen. Let's continue. First part, 2 times negative 27, that's multiplication. So we're going to perform that when we will obtain negative 54. The second part, negative 1 times 25, that is negative 25. And then we combine these two. You could think about money, right? You owe someone $54 and then you owe someone $25. In total, you owe that someone $79. So the answer will be negative 79. Number 2. Evaluate this expression when k is negative 2 and p is 3. We only have 2 variables. I highly recommend that whenever you evaluate, rewrite the expression, replace the variable with a pair of grouping symbols, so it's easy for you to insert later. First, we have k, so I'm going to leave a space, put a pair of grouping symbols, and cubed, followed by p squared minus 5k squared and p. So notice that for the variable part, I just put a pair of grouping symbols. And then we're going to insert. I'm going to use a red to insert the values. First position is for k, and k is negative 2, so you replace with negative 2. And then p is positive 3. Second part, k is negative 2, p is positive 3. Now, number 2 simply becomes number 1. So you follow the order of operations. Let's calculate. Exponent first. Negative 2 raised to the 3rd power. You multiply negative 2 3 times. That's negative 8. 3 squared, that's positive 9. So that's the first part. Minus 5. So you have to leave that because we have to do exponent first. Negative 2 squared, that is positive 4. And then you also have a 3. Now let's further simplify. Negative 8 times 9, that's negative 72. Negative 5 times 4 times 3, that's negative 60. And again, we are owing someone money. You owe someone $72, you owe someone additionally $60. In total, you owe someone negative $132. So the answer is negative 132. Number 3. Simplify the following expressions completely. For number 3, all you need to do is using distributive property. So I highly recommend that you do these little curves to help you identify the products that you have to calculate. Starting with the first part, we're distributing positive 7 into the first pair of parentheses. You multiply every single term by positive 7. 7 times 3, that is 21. And then 7 times negative 2b. So you simply multiply 7 by negative 2 first. That will give you negative 14, and then you just copy the b, because you simply just multiplied them. Second part, however, you have to be careful because you have a negative 2 outside. So when you distribute, you're going to multiply every single term inside by negative 2. Negative 2 times 14, that's negative 28. Negative 2 times negative 3b, that is positive 6b. So this is what happens after you distribute. And then we're going to combine like terms. 21 minus 28, that is negative 7. Negative 14b plus 6b, you combine their coefficients, negative 8b. So the answer is negative 7 minus 8b. Number 4. Number 4, we don't have variables, we only have numbers. So you simply just follow the order of operations. We will do the numerator and the denominator separately because there is an invisible parentheses around the numerator and the denominator. So you do have grouping symbols. On the top, 3 squared, that is 9, minus 5 squared, that is 25. On the bottom, 5 minus 9, that is negative 4. And then we're raising it to the second power. Keep going. 9 minus 25, that is negative 16. And negative 4 squared, that gives you positive 16. We simplify this. Negative 16 divided by positive 16, that is negative 1. So number 4, the answer is negative 1. Number 5, translate into an algebraic expression. When you translate, you simply follow the order of the words and translate part to part. 6 more than 5 times the difference of a number and 7. So starting with the first part, 6. That's simply just 6. And then you have this more than. More than, I know a lot of people would attempt to translate to greater than, but make sure that you don't do that. In this case, we're using an operation to represent more than, which is addition. If it's less than, then it's going to be a subtraction, but you have to put the 6 in the second position. So that's just the convention that we use. So here, 6 more than, it's simply 6 plus. And then you have 5, that is simply just 5, times. So times is just multiplication. The difference. So this part might be a little bit difficult. It's the difference of. The difference of, usually this structure indicates that what follows will be 2 numbers. You're finding out the difference between those 2 numbers. Therefore, this simply translates to a minus sign in between 2 quantities. What follows will go into those 2 positions. Let's check out what follows. It says a number and 7. So I think 7 is easy to translate, so you just translate as 7. For a number, since we don't know what that number is, then you could give a variable. For example, you could make it x. And then do not forget that we have to put a pair of grouping symbols around the difference. So the difference, you put a minus sign in the middle, and also at the same time, you could also put the grouping symbols around the 2 empty spots where you have to place the numbers that follow the difference of. And this completes our expression. So let's rewrite the expression. 6 plus 5 times x minus 7. And we have grouping symbols around x minus 7. So that's number 5. Moving on to page 2. Starting page 2, we have chapter 2, which talks about linear equations and inequality. Number 6, solve for x. When you solve for x, most of the time, what you're going to do is first, using distributive property to get rid of grouping symbols, and then combine like terms on each side, and then you isolate variable x and solve for x. So for this problem, first we're going to distribute -3 inside. On the other side, I'm going to put an invisible 1 outside, and then distribute this -1 inside. So step number 1 is distribute. Let's distribute -3x, and then -3 times -7, that's +21, plus 11 equals, on the other side, -1 times 8, that's -8. -1 times -5x, that's +5x. So that's the first step. Second step, do not move them yet. What we're going to do is we're going to combine like terms. So you're going to check out each side. If we have like terms, we're going to combine them. On the left hand side, we have 21 plus 11. Those two are like terms. If you add them, you get 32. On the right hand side, however, we don't have any like terms, so we cannot do anything. And then the next step will be performing inverse operations on both sides to isolate variable x. So number 3, isolate x by performing inverse operations. Notice that we have x on both sides of the equation, so you have to make a decision. Should you put the x on the left side or the right side? In my opinion, in this case, I'm going to put the x on the right hand side because it will give me a positive coefficient. That means we're going to move this -3x to the other side. So perform inverse operations. -3x, the opposite is +3x. And you're going to do the same thing on the other side. And let's write down what happens after this. The -3x and +3x on the left hand side canceled out, so you only have a 32 left. On the right hand side, you have -8 plus 5x plus 3x, that is ax. So we moved x successfully to the right hand side. And then since we need to isolate x, we need to get rid of that -8. So perform inverse operations. The opposite is +8. And then you have to do that on the other side as well. And that gives us 40 equals ax. This is a pretty simple equation. To get x, we divide both sides by coefficient of x, which is 8, and we obtain 5 equals x. Therefore, the solution is simply x equals 5. You could also write 5 equals x if you want. Number 7, solving inequalities. Since the space is limited, I'm going to write it right here for number 7. Let's copy the original inequality first. Once you copy it down, let's double check. 2 times 3x minus 7 minus 5 greater than or equal to 10x minus 7. Very good. Also, some people might think this 7 is part of the number. It's not. Let's just move it far away. It's not part of the problem. It's just the question number is 7. Okay. First step, same as solving equations. We're going to distribute to get rid of grouping symbols. There's only one number that we have to distribute on the left hand side. Multiply each of them inside by 2, we obtain 6x minus 14. Copy the rest of the inequality. And now we have the same situation as before. X, the variable, is on both sides of the equation. Therefore, you're going to determine which side you would like to have x. Usually for inequalities, we would like to have the x on the left hand side. So I'm going to move this 10x to the left hand side. Inverse operation, subtracting 10x, and you have to do the same thing on the left hand side. That's going to give us negative 4x minus 14 minus 5 greater than or equal to, these two cancel out, negative 7. We could combine the two like terms on the left hand side, negative 14 and negative 5. That's simply negative 4x minus 19 greater than or equal to negative 7. So I actually forgot to combine negative 14 and 5 earlier. It's probably good. It's probably better if you combine negative 14 and negative 5 first before you subtract 10x from both sides. Alright, the next step, we're going to keep isolating x, doing inverse operations. We're going to move that negative 19 to the right hand side. And that's going to give us negative 4x on the left hand side, greater than or equal to negative 7 plus 19, that is positive 12. Next step, we're going to divide both sides by coefficient of x, just like how we solve equations. However, there's one thing that you need to do. Because we're trying to solve an inequality and we divide both sides by a negative number, you have to reverse the inequality symbol, change the direction from greater than or equal to less than or equal to. Very important. Finally, we write our final solution, x less than or equal to 12 divided by negative 4, that is negative 3. So this is our final solution. Let's write over here on the line, x less than or equal to negative 3. That is number 7, part A. Part B, graph the solution on the real number line. So if you're going to graph the solution, make sure you mark the number line. Usually I mark 0, negative 1, negative 2, negative 3. I think that's good enough. But if you want, you could add more numbers if you like. First, let's determine the kind of circle that we're going to have. Since x is less than or equal to negative 3, we're going to have a closed circle at negative 3. Make sure you fill the circle. And then, since it is less than or equal to, it's pointing to the left. So that will be the graph. If you're using a pencil, what you could do is you could do a closed circle at negative 3 and then pointing to the left. Same as what I just did. The only difference is you don't do it on the number line because pencil, the color is the same as the black color. It might be harder for me to see what your arrow is. So you might want to do it above the number line. Number 8, solve for A. This is an equation that has fractions. For equations that has fractions, I highly recommend that you find out LCD first and then figure out what operation you need to do to both sides of the equation in order to isolate variable. Let's use LCD to solve number 8. Check out the denominator. We have 4, 3, and 2. LCD in this case will be the least common multiple of all the denominators that you see, which is 4, 3, and 2. Find out the minimum number that's divisible by all these 3 numbers. So there's a little trick that you can use, starting with the largest number among all, which is 4. And then you check out, is 4 divisible by other numbers? 4 is not divisible by 3. So you're going to move on to the next multiple 4. How do you find out the next multiple 4? You simply do 4 plus 4. And that is 8. And then you do the same procedure. Is 8 divisible by 3? No, it's not. Therefore, we're going to move on to the next multiple of 4, the multiple after 8. How do you find that? You keep adding 4. 8 plus 4 is 12. And then you check, is 12 divisible by 3? Yes. Is 12 divisible by 2? Yes. Therefore, your LCD is simply 12. Once we find out this LCD, I'm going to multiply the entire equation by our LCD, which is 12. So let's write down after I distribute, because I have 3 terms inside of my equation. So I have to distribute the 12. Once I distribute, on the left hand side, you have 12 times a over 4 minus 12 times 2 over 3 equals 1 over 2 times 12. Make sure you multiply every single term by 12. And then, here's the tricky part. I'm going to divide 4 into 12, write a 3 next to 12 because there are 3 4s in 12. For the second part, divide 3 into 12, you have a 4 because there are 4 3's in 12. The one on the right hand side, divide 2 into 12, you have 6 2 in 12. Notice that no denominators exist anymore. All the denominators are gone after I multiply everything by LCD. That is the whole purpose of multiplying both sides by LCD, to get rid of all the denominators. Let's write down what's left. On the left hand side, you have 3a, and then you have a minus sign. 4 times 2, that is 8, equals 1 times 6, that is 6. So this is an equation that's much easier to solve. Perform inverse operations, so we're going to plus 8 on both sides. And if you do that, we will obtain 3a equals 6 plus 8, that is 14. Divide both sides by a coefficient of a, which is 3. We obtain the value of 8 is 14 over 3. Let's write down our solution. A equals 14 over 3. Number 9. Annabelle has $6.25 in dimes and quarters. The number of dimes is 4 less than the number of quarters. How many of each coin does she have? And the requirement is must write and solve an algebraic equation for credit. That means if you simply guess and you figure out the answer, it doesn't count. So you have to actually solve using algebraic equation. If you check out the right hand side, you have number of dimes, number of quarters. So that will actually be our variables. We basically assume the number of dimes is D and the number of quarters Q. Make sure that those are your variables. And then we're going to write down 2 equations. Those 2 equations comes from the 2 sentences that are in this 3 sentences problem. First sentence, she has $6.25 in dimes and quarters. How many cents are there in dimes? Well, you might remember it's 10 cents. So if I have D dimes, I simply multiply D by 10, and that's going to give me the total number of cents in those dimes. And I could do the same thing for my quarters. Each quarter has 25 cents. If I have Q quarters, then the total number of cents will be 25 times Q, or 25Q. If I add the cents in these 2 types of coins, and that should be matching whatever she has originally, which is $6.25. So here's the question. How many cents are there in $6.25? The answer should be pretty easy, 625. Notice that I use cents as the units because I want to avoid decimals. Second equation, coming from the second sentence. So it's very similar to number 5 on this exam where you have to translate. The number of dimes is 4 less than the number of quarters. So let's analyze each part. The number of dimes, we already have a variable for that, which is D. And then you have is, that is equal sign. And then you have 4 less than. So here you have to actually check out the operation in the middle. It's less than, so it's something minus 4. Let's write that out. In this case, this one will be something minus 4. So you have to leave a something. The something is the number of quarters. The number of quarters. That is the something that we are subtracting from. And we also have a variable for that, which is Q. So put it over here. Therefore, the second sentence translates to D equals Q minus 4. So we have these 2 equations, and they do want you to solve. So personally, I think the best way to solve will be substitution. Substitute the second equation into the first, because in the second equation, the variable D is already isolated. So let's plug it in. Since the space is limited, I'm going to write on the right hand side. The first equation is 10D plus 25q equals 625. Let's plug in d equals q minus 4. So I'm going to leave a space for d. Replace it with a grouping symbol, just like how we evaluate expressions. And then insert the expression that we have in the second equation, which is q minus 4. Copy the rest of the equation, 25q equals 625. So that is the substitution. Now we have equation in one variable, which you should be able to solve. So first, we are going to distribute this 10 into the parentheses. That's going to give us 10q minus 40 plus the rest of the equation, just copy. And then, notice that we have variables in two parts. So we're going to combine like terms on the left-hand side. 10q plus 25q, that is 35q, minus 40 equals 625. Now we're going to isolate q. Perform inverse operations. So plus 40 on both sides. We obtain 35q equals 665. Dividing both sides by coefficient of q, which is 35, we obtain our answer for q, or the number of quarters. It's 19. So you could simply do a long division. You should be able to get that 665 divided by 35 is 19. Let's actually carry out the long division for you. So 665 goes inside, 35 goes outside. There are a maximum 135 in 66 with a remainder of 31. Drop down the 5. And then this number, if you try several digits, you will find out that it's actually 5. 5 times 9 is 45. 3 times 9 is 27. Times 4 is 31. So we have a remainder of 0. That's why it's 19. Therefore, the number of quarters, because our variable is q, is 19. So you write 19 right here. The other one, what's the number of dimes? How do you find that out? Well, remember we have that equation, which is right here. D equals q minus 4. So we simply plug it into this one to find out d. D is q minus 4. D equals, our q is 19. Copy the rest of the equation, minus 4. Therefore, d is simply 15. Write down 15. So that is number 9. As you can see, number 9 is a little bit tedious. You have to first translate, create a system of equations, and then you solve the system of equations to get your answer. Number 10, solve for k. 3m equals 5l plus 4k. So I highly recommend that you circle the variable that you need to solve. We're trying to solve for k. Highlight that. And then you're going to do inverse operations. So apparently we need to get rid of that 5m. Since the space is limited, I'm going to do it right here. Let's copy the original. It's 3m equals 5l plus 4k. Highlight or circle the variable you need to solve. So apparently we need to move that 5l to the other side. So perform inverse operations, subtracting 5l from both sides. On the left hand side, it's simply 3m minus 5l. On the right hand side, the two 5l's got cancelled out. You have 4k left. Keep circling the variable. We still need to isolate this k, and there is a 4 in front of k. So we simply divide both sides by coefficient of k. On the left hand side, you divide each of them by 4, or you could just simply write as the original left hand side over 4. Therefore, we have our k equals 3m minus 5l over 4. And that is our answer. K equals 3m minus 5l over 4. Number 11. Study number 11, we're dealing with chapter 3 on linear equations and inequalities in two variables. Part A, find the x and y-intercepts of the equation 2x minus 7y equals 14. So in class, we talk about how to deal with this kind of equation and find out x and y-intercepts. X-intercepts is where the line crosses the x-axis. Y-intercept is where the line crosses the y-axis. All you need to do is simply create a table, if you remember from our class. The table will look like this. So you have a 0 for x, you have a 0 for y. The first two numbers, these two numbers, will tell you the y-intercept. And the second two numbers will tell you the x-intercept. And how do you find out the values? You simply plug it in. So for the blue part, plugging x equals 0, you could simply cover the 2x. That's going to give you negative 7y equals 14, because the 2 times 0 is just becomes 0. Dividing both sides by negative 7, we obtain y is negative 2. So the number here is negative 2. That is the y-intercept. Or you could write as 0, comma, negative 2. And that is the y-intercept. For the x-intercept, we plug in x equals 0. If you plug in, for the x-intercept, we plug in y equals 0. So if you plug in y equals 0, we have 2x minus 7 times 0, which is just 0, equals 14. Dividing both sides by 2, you get x equals 7. Therefore, this number is 7. And when you write your x-intercept, you could simply write as 7, comma 0. And these are our x-intercept and y-intercept. Part B, plot the intercepts and use them to draw the graph. So you simply plot those 2 points. 7, 0. On the x-axis, locate 7, 0. 1, 2, 3, 4, 5, 6, 7. So it's right here. That is the 7, 0. Y-intercept 0, negative 2. So we're going to go down 2 times. That is your y-intercept. Let me use red. Actually, our y-intercept is blue, right? So actually, y-intercept is blue, and then the x-intercept is red. Alright, so now this matches with the color that we used earlier. To graph, we simply connect them. And then extend a little bit. So this will be our line. And that's number 11. Number 12. Find the slope of the line graphed below. Write the slope in simplest form. So for slope, if you remember, slope m is rise over run. So in our class, we use a slightly different formula. We say it's v over h. You just need to find out the vertical movement over the horizontal movement. So I'm going to pick 2 points from the graph. First point I'm going to pick right here because this point is very easy to identify. Let's call it point A. And then second point, let's call it right here, point B. All you need to do is find out V and find out H. So let's actually find it out. V over H. And our movement is from point A to point B. From point to point B, vertical movement, you have to go down. How many times? 1, 2, 3, 4, 5. 5 times. So it's negative 5. That is your V, right? Therefore, the first one is negative 5. Over horizontal movement. And then we have to go to the right 2 times. And that is positive 2. So your horizontal movement is 2. Let's simplify this. You could write as negative 2.5, or you could write as, take out the negative sign, negative 5 over 2. So this is your slope. Make sure you write it over here. M equals negative 5 over 2. That is the slope. Number 13. Find the slope of the line through the given points, negative 12, 4, and 2, negative 3. Write the slope in simplest form. So we did similar examples in class, if you remember. We are going to find out the slope using the formula, which is y2 minus y1 over x2 minus x1. That is if you have 2 points and you want to find out the slope. Simply plug it in. Before you plug it in, make sure you label your points. x1, y1, x2, y2. And now let's plug it in. Before you plug it in, I'm gonna use the same technique that we used before, using grouping symbols to replace the variables. The benefits of doing this is to avoid careless mistakes. Now let's plug it in. y2 is negative 3, y1 is positive 4, x2 is 2, x1 is negative 12. So notice that when you have negative numbers that you have to insert, especially if it's in the second position, you will have 2 negative signs ended in the expression. So it's very important that if you do the grouping symbol, it's very easy to see there are 2 negative signs. Now let's calculate. On the top, negative 3 minus 4, that's negative 7. On the bottom, 2 minus negative 12, it's the same as 2 plus 12, that is positive 14. Let's simplify this. 7 and 14, you could actually divide them and simplify. I could divide 7 by 7, that cancel out and become 1. I divide 14 by 7, that's going to give me 2. Therefore, it can be reduced to negative 1 over 2. And that is the slope. Let me write it over here. M equals negative 1/2. Number 14. Given the equation 4x minus 5y equals negative 20, determine the slope and the y-intercept. So if you remember, there is a form called the Slope-Intercept Form, which gives us the slope and the y-intercept. So that's pretty much what we need to do. We need to convert number 14, the equation, into Slope-Intercept Form. So let me write it over here. 4x minus 5y equals negative 20. And that is the equation. It's the general linear equation form. We're going to convert this to the slope-intercept form. So if you remember, slope-intercept form, y equals mx plus b. And that requires you to have a y on one side of the equation. Circle y, because that's what we're going to isolate. And that basically becomes problem number 10 on your exam, solving for one of the variables. First, inverse operation, minus 4x from both sides. And on the left hand side, do not forget the negative sign. You have negative 5y equals, on the right hand side, I'm going to switch the order, write as negative 4x minus 20. The reason that I switch the order is because in the slope-intercept form, the x term comes first. And then we divide both sides by coefficient of y, which is negative 5. And on the right hand side, instead of writing everything over 5, I'm going to write each of them over negative 5. Let's calculate. On the left hand side, you have a y. On the right hand side, divide the coefficients. Negative 4 divided by negative 5. That is simply 4 over 5. And write the x next to it, so it looks closer to the slope-intercept form. And finally, you have that constant division. Negative 20 divided by negative 5, that is positive 4. So we obtained our slope-intercept form. By looking at the slope-intercept form, the coefficient of x is the slope, and the constant term is the y-intercept. So let's write down our final solution. For number 14, slope is 4 over 5. Make sure you don't include the x. Slope is simply the coefficient of x in your slope-intercept form. Y-intercept is 4, so you could write as a 4, or you could also write as 0, 4, which is probably better. So that's number 14. Number 15. Find the equation of the line that passes through the point a -3 and has a slope of -3/2. Write the answer in slope-intercept form. We also did similar problems in class. Let me write over here. Let's copy all the information so that we know what we are dealing with. We're giving a point a -3. We're also told that the slope is -3/2. Before you proceed, make sure you double check. A -3, -3/2. A -3, -3/2. So everything's correct. How do you do that? Remember slope-intercept form, it's still on the left-hand side, y equals mx plus b. So that's what we need. We need to find out the slope, m, and b. The slope is already given, right? M is -3/2. We just need to find out b. How do you find out b? Well, if we know x and y, then with the help of n, we will be able to solve for b. Do we know x and y? Yeah, we do know x and y, because they gave you a point. That point is on the line. That means that point satisfies the x and the y in the equation. Therefore, we simply first write the slope-intercept form, y equals mx plus b, and then plug in the values. Y is -3, so it's -3 below y. M is -3/2, so we just write -3/2 times x. X is 8, so times 8. And then you copy the rest of the equation. You have an equal sign right here, and then you have a plus b right here. And that is the equation that we have. In this case, we only have one variable, which is b. So it should be very easy to solve. Let's calculate. On the left-hand side, it's just -3. On the right-hand side, I could divide this 2 into 8 and write as a 4 next to 8, because there are 4 2's in one 8. And then you multiply the numbers on the top. -3 times 4, that's -12, plus b. B is on the right-hand side, so perform inverse operations. We need to get rid of this -12, plus 12 on both sides. We obtain 9 on the left and b on the right. Therefore, we have m, we have b. You put it back into the slope-intercept form. Y equals m is -3/2 times x plus b. B is +9, so plus 9. And that is basically your slope-intercept form. Let me copy it back to the line. Y equals -3/2x plus 9. Alright, finally we're doing the last chapter. Chapter 4, System of Linear Equations. Number 16. Determine if the ordered pair -phi1 is a solution to the following system. Must show work to receive credit. So how do you show work? Let me write it over here, number 16. So all you need to do is basically plug it in. We have two equations. Let's write down the two equations. 3x plus 4y equals -11. And then you have the other equation, 4x minus ay equals -20. So you simply plug in the point, -5 and 1. And those basically are x and y's. So you just replace x with -5, replace y as 1. 3 times x is -5. -5. Plus 4 times y. And then the y is 1. And then put a question mark above the equation, equal sign, because we don't know whether or not they're true. Let's calculate. 3 times -5, that's -15. Plus 4 times 1, which is 4. Is this equal to -11? -15 plus 4, it's -11. Is this equal to -11? Yes, it is true. So we cannot conclude anything yet, even though it's true, because we have another equation. So we need to check the other one as well. Same thing, I'm gonna do the grouping symbols to replace the variables. And let's insert the variables. X is -5, y is 1. Let's calculate. Make sure you put a question mark above the equal sign. 4 times -5, that's -20. -8 times 1, that's -8. And we're checking whether or not it's equal to -20. -20 minus 8, that's -28. Is -28 the same as -20? No. So it's false. As long as one of them is false, then your conclusion is 5 -1 is not a solution. To write above the line, you simply say no. But if you want to show work, this is basically the work that you're going to show. Moving on to number 17. Solve the system. 2x minus 3y equals 7, x plus 4y equals -13. Let me write right here, number 17. 2x minus 3y equals 7, x plus 4y equals -13. Let's double check, see if our equations are correct. 2x minus 3y equals 7, x plus 4y equals -13. Very good. By looking at these two equations, I would say the best method to solve will be combination method that we discussed in class. Because both of the variables are on the same side of the equation, on the other side you simply have a constant. So we're going to make a choice. Which variable would you like to eliminate? What I'm going to do is I'm going to eliminate x. So I choose to eliminate x. And of course, you can also eliminate y if you want. To eliminate x, you need to figure out what kind of transformation you need. And that requires us to find out the least common multiple of all the coefficients for x currently in the system. We have two coefficients. In the first equation is 2. Second equation, there's an invisible 1 right here. So it's simply 1. Let me put it as a red. Therefore, the least common multiple is simply 2. That means we're going to make the coefficient +2 and -2. The first equation already has a coefficient of x that's +2. So I'm going to make the second equation coefficient -2. Originally is +1. I simply multiply this by -2, and that's going to convert this to -2. Let's write down the new system. First equation is the same. 2x minus 3y equals 7. Second equation, distribute the number that you're multiplying to each component in the equation. First one is -2x, and then -ay equals, on the right hand side, -13 times -2, that's +26. Now we are ready to add the two equations that we just transformed. When we add those two equations side by side, the x term cancel out. -3y minus ay, that's -11y, equals 7 plus 26, that is +33. We divide both sides by coefficient of y, which is -11. We obtain y equals -3. So that's basically one of your solution. We need to find out the value of x. To find out the value of x, there are multiple ways. You could plug it back into one of the original equation and solve for x. So I'm probably going to use the second equation. If you notice the second equation, it's x plus 4y equals -13. X is already by itself with a coefficient of 1. So all I need to do is just plug it in, the value for y. X plus 4, grouping symbols, equals -13. The y that we're going to plug in is the solution that we found earlier, which is -3. Let's simplify this. X, 4 times -3, that's -12, equals -13. Keep isolating x. We're going to plus 12 to both sides. And that keeps us x equals negative 13 plus 12, that's negative 1. Therefore, we find the other half of the solution, x equals negative 1. And of course, it's always recommended that you plug these two values back into both of the two original equations and check whether or not this order pair is a solution. Once you check them and you confirm that it is the solution, then you're going to write your solution right here as an order pair. X is negative 1, y is negative 3. So the point is simply negative 1 and negative 3. And that is number 17. Number 18. The sum of two numbers is 40. One number is 8 less than 3 times the other. Find the two numbers. This question, just like before, you must write and solve algebraic equations in order to receive credit. Let's write over here, number 18. Since we have two numbers, I'm going to assume that they are x and y. So you could make sure that one of the two numbers are x and y. First sentence, the sum of the two numbers is 40. So you simply do x plus y equals 40. That will be one of your equations. Second equation is the second sentence. One number is 8 less than 3 times the other. So we could just make one number x and the other number y, and then translate. One number, that is x, is equal sign a less than. So notice that this a less than has to be translated to something minus 8. And then that something is what follows less than. In this case, is 3 times the other, so 3y. Therefore, on the other side, we have 3y minus 8. So you just have to translate pieces by pieces. These are the two equations. The best way to solve this system will be substitution. Substitute the second equation into the first, because in the second equation, our variable x is already isolated. Let's plug it in. Write the first equation, x plus y equals 40. Since we're replacing x, I'm going to write a grouping symbol instead of x. Plus y equals 40. Plug in the expression for x, which is 3y minus 8. Now let's simplify this equation. First, you have a grouping symbol. You could totally get rid of it because there's an invisible 1 outside. So if you distribute this invisible 1, it doesn't change anything. Therefore, we simply have 3y minus 8 plus y equals 40. And then we're going to combine like terms. On the left-hand side, 3y plus y, that is 4y. Minus 8 equals 40. Keep isolating y. We need to add a to both sides. And that's going to give us 4y equals 48. Divide both sides by coefficient of y, which is 4. We obtain y is 12. Therefore, we already have the solution to one of the numbers. One of the numbers 12. How do you find out the other number? Well, you have two ways. One is using the first relationship. They add up to 40. If one is 12, then the other one has to be 40 minus 12, which is 28. Or you could use the second equation in the original. So I think the sum is easier in this case. I'm just going to use x plus y equals 40, replacing y with 12. Therefore, x is simply 40 minus 12, and that is 28. You could also check that 28 is 3 times 12 minus 8. So let's write down the two numbers. X is 28, y is 12. Number 19. Determine a system of linear equation that can be used to solve the following problem. And it also says do not solve the system of equation, just write the two equations below. Make sure you read the instruction carefully, because in the past, students always solve this problem for no reason. You don't need to solve the system. You just need to write the two equations. Let's read the problem. An exhibition sold a total of 450 tickets. Regular and discounted tickets were sold. The price for each regular ticket was $27, and each discounted ticket was $18. A total of 10,440 in ticket sales was collected. How many of each kind of tickets did the exhibition sell? First, we need our variables. You could assume that the number of regular tickets is R and the number of discounted tickets is D. Just like the dime and quarter example, we always assume the quantity as the variable. Now we need two equations. First sentence, it tells you that the total number of tickets that was sold was 450. Therefore, R plus D is 450. Because our variable R and D, they represent the number of tickets of each type that was sold. Therefore, R plus D is 450. Second equation has something to do with the unit's price and the total. Each regular ticket was $27. So if I have R of them, then the total income by selling those R regular tickets will be 27 times R. Same thing with the discounted tickets. Each of them is $18. And we have D of them, so you do 18 times D. That's going to be the total income from those discounted tickets that were sold. If I add them up, it's going to give me the total income that were collected, which is 10,440. And that completes our problem. We have two equations. That's it. Finally, number 20. Solve the system. So number 20 is very similar to number 17. The only difference is this time, one of the variable is isolated. If you look at it, variable y in the first equation is already isolated. Therefore, for number 20, the best way to solve will be substitution. So let me write the solution right here. All you need to do is substitute the first equation into the second equation. Let's write down the second equation first. 15x minus 3y equals 9. And I'm going to replace y with the first expression that we have. Let me rewrite the second equation, replace y with grouping symbols, and copy the rest of the equation. Inside the grouping symbol, you're going to write the right-hand side of the first equation, which is 5x minus 3, because that's the part that we are substituting. And then we are going to get rid of the grouping symbol in this equation. There's an equation in one variable x, so we should be able to solve with no problem. Distributing negative 3. Since they have a negative sign, make sure you distribute along with the negative sign. Copy the first term, 15x. Negative 3 times positive 5x, that's negative 15x. Negative 3 times negative 3, that is positive 9, equals 9. Combine like terms on each side. On the left-hand side, funny thing happened. 15x minus 15x, they cancel out. All we have left is just a 9 on the left-hand side. On the right-hand side, you also have a 9, and then you have an equal sign in the middle. We get something that's always true, right? 9 equals 9. So this one, always true. Regardless of the value of x. If you see something that's always true, then your conclusion will be infinitely many solutions right away. That basically means that it doesn't matter what your x values are, as long as you satisfy one of those two equations, then it will satisfy the entire system. So that means we have infinitely many solutions. In this class, you could simply write like that. So you could just write that here, infinitely many solutions. Alright, that completes our discussion of midterm exam. Make sure you study this exam carefully. Once you go through these problems with me through this video, I highly recommend that you start from scratch, give yourself some time, and do all these problems on your own and see if you could still figure out the correct answers. Make sure you do it not right after this review, but maybe on a different day or in like more than 10 hours. So in that case, it's actually more useful. You will actually test whether or not you remember this only by short-term memory or actually by understanding the concept. Well, good luck on your midterm. I will see you on our virtual session in the future.